How we doing? So here we are again, back at it. This is Unit 2. You survived Unit 1 and you showed up for another day. Congratulations, I'm proud of you. Right? Not everybody's here. I can tell you right now, somebody left between now and then typically. But for those of you that are here, good deal, and we're going to get through this. I'm telling you, I can get you through this class, I promise. If you just work at it, we can get you through. All right, so we learned about tables and how to organize our data, and we learned the language of statistics, right? Like I said earlier, language is everything. You need to, no matter what it is, you need to be able to talk to your peers, and they need to understand what you're saying. So in journal articles and writing, scientific journals, that type of thing, this is how people communicate. And of course, you don't want to just see dry data, right? We like some pictures too, right? So everybody likes pictures in their book. They have to read less, right? So one of the pictures that we like is a histogram. Right? Very similar to a bar graph, right? You've seen bar graphs, I'm assuming, previously, right? So a histogram is very similar to a bar graph. However, the bars all touch. Anyway, this is a histogram. This is what we do, and this is how it's organized, right? So here is F. This is what we call the y-axis. The vertical axis is the y-axis. Right? The y-axis, or the ordinate, right? Don't have to worry about that as much. But this is the y-axis, or the ordinate. Right? Horizontal one is the x-axis. Okay? So on our y-axis here, we have the frequency, right? So when we go back to the frequency, the number of people that got the score, right? So in this case, the highest number of people to get one score was 8. So that's where our columns went, right? This is the x-axis, which has our scores, the hibiscus. Yeah, look how to spell it. See? Okay? The x-axis. I just keep using the x-axis. So this has our range of scores. And just like previously, these scores have groupings, right? The lowest score is 12 and the highest score is 71. So we don't want that long list of scores. We couldn't possibly have room for it. I don't have room for it on the board, and I don't want to write out all that stuff. And neither do you. So we group our scores, and in this case, instead of 3s like our last tables, we did 5, right? 12, 13, 14, 15, 16, groupings of 5, like I mentioned when I went over it previously. These two marks represent the scores that are missing between 0 and 12. It represents the fact that nobody scored between a 0 and 12. And so the first person on the lowest score was 12, and that's where we started our table, rather than including scores that nobody got. Okay? And it's very simple. You go across. One person got a score between 12 and 16, right? We make a line, we make our little bar. 2 people got 17 to 21, make our line, and make our little bar. Nobody scored between 22 and 26. 2 people then went back, and on and on. 5 people scored between 32 and 36. 8 people scored between 37 and then. And here you can see, right, again, most of the scores are in the middle, right? Pretty much the highest number of people scored almost right exactly in the middle. And we'll talk about this occurrence a lot during this class, okay? So basically, this is what a histogram looks like. Again, you can put it on paper. Lowest scores go in the bottom. The corner is always 0. The lowest scores start on the left and move to the right, just like you're reading it in the paper. Same thing, the lowest scores start on the bottom and go up just like in your column, in your table, right? I am a terrible artist, anybody will tell you. So theoretically, it should be what we call a 3-to-5 ratio. So if this y-axis was 3 inches, the x-axis should be 5 inches. Right? Of course, mine's a little more symmetrical, but that's the idea. The x-axis should be longer than the y-axis. Okay?
Why?
That's just the way it's done. Right? So there's a lot of rules, right? We talked about the rules of math. This is just the rules. It doesn't matter. Somebody's decided this is the way it was going to be a long time ago, and we've been doing it that way for all this time. It may be cutting the ends off the ham, I don't know, but it's the same thing, right? We do things because it's tradition. We do things because this is what the culture of statistics expects, right? If you've been in other things, you know that there's expectations, and this is what is expected, and these are the rules. So you just follow the rules, right? We label the histogram. In this case, I don't know what it is, so it's just an example of a histogram, right? And the same thing, you can put a little note of what it is, you know. So I could say anything about this. This is a histogram, and it's the scores of reading test, right? I mean, you just say whatever. Right. All the bars are supposed to be the equal width. Again, I'm not the greatest artist, so it might not be the best, but the idea is to make everything look nice and pretty and square or rectangular, right? As I said, this represents scores that you do not need. And there we go. And that's our histograms. You will see them often in research articles. Hopefully you've seen some research articles, you've taken Psych 1, you're doing something, you started reading some books, you've seen some kind of social science material before, so I'm thinking this is not totally unfamiliar with you, but now you know the language that goes along with it and how to set one up. Another way that we picture, put our data into a picture is a different type of graph, is called a frequency polygon. All right, and they call it a polygon because it is made up of straight lines. So that's the difference. We're going to talk a lot about curves in this class, but right now the polygon is called that because it's made up of straight lines, and I'm going to show you what I mean when I say that. All right, so here's the table of our data. All right. Our scores range from 15 to 22, and here's the frequency of each score, right? And now I've translated this into this frequency polygon. So what does that mean that I did? So the rules apply the same. These are, right, distribution of depression scores. A table, right? Distribution of depression scores. I label it. Just like I did with the histogram and all of my tables, right? Same reference points, 3 inches, right? The ratio is 3 for the y-axis to 5 on the x-axis. This one I actually got probably a little closer. Right? And the same thing, my frequency is on the y-axis and my scores are on the x-axis. So, as I said, the scores range from 15 to 22, right, when you look at the table. However, in my polygon, I start with the one score lower than the actual first score, and I add one on the high end also. And this is demonstrated by the dotted line going to the actual first score. And again, these lines represent there's nobody between 0 and 14. Yes?
Why do you do that?
Same thing, because these are the rules, right? This is the way everybody expects to see it. It's real simple. It's what I keep saying about math, right? People that think math is hard, to me, math is one of the simplest things, right? If you're a social scientist, a therapist, you spend a lot of time in the gray area. Like you're making your best educated guess to diagnose somebody. You're making your best educated guess about how to treat somebody. But the math, it's a hard and fast rules. Like this is the rule. You just do it according to the rules and everybody's happy, right? So it's just the way it is.
Do you only do that with these types of graphs, or would you, like how you added onto each end?
Yes, that's for this occurrence.
Okay.
Right? We're gonna, and like I said, for the rest of the semester, we're really probably gonna be talking about curves rather than polygons. So, okay. But this is the way it is. You add one below, you add one above. I'm sure if you want to study the history of math, there's a class for that too. If you're really interested, right? Some mathematicians though. Anyway, the way I got this though, and the reason it's the straight lines is because what I did was I plotted my points first, right? So I went to 15 and one person got 15 and I put my point there. Nobody got a 16, I put my point there, right? 2 people got 17, 5 people got 18, and so I marked out all my points and then I connected them by straight lines. And yes, though you may not believe it, those are straight lines, okay? And that's why it's called a polygon, because the shape is made up of straight lines, okay? And this is our polygon. This is a distribution of our scores. It's the translation of our table and our data into another kind of picture. So we're back, and you don't know it probably, but because my editor is so good, but I've actually stopped and changed the board in the meantime, right? So just like our other examples, when we have a larger group number of scores, right, when our scores range from 4 to 43, we don't want, or in this case it's actually 6 to 41, we don't want to have to make that long list, right? So we do intervals just like we did with all our other examples, right? So in this case, in our table, we did groupings of 3 again, 6, 7, 8, 9, 10, 11, 15, 16, 17, etc., right? Intervals of 3. And here's our frequency, the number of people that got in that score grouping. In this case, however, we put the midpoint of the scores, right? So 6, 7, 8, 7 is the midpoint. 9, 10, 11, 10 is the midpoint. Right? 13 is the midpoint of the interval. So this is the midpoint of the intervals that we chose to do. Does that make sense, I hope?
Yeah.
Okay. So then on our polygon, right over here, we list the midpoints instead of the groupings. Like if you remember on the histogram, I had the interval written down, the entire interval. However, in this case now, we just use the midpoints. And again, I'm going to add 1 below our starting score, our starting midpoint, and I'm going to use that same interval. So 3 was our interval, right? So if 7 is my first midpoint, my starting midpoint is 3 below that, or 4. And the same thing on the other end. My top midpoint is 40, but I'm going to add another one, the next step, right? And so I add 3 again, the size of our interval. And my x-axis ends on 43. Once again, we have another symbol, but this still means the same thing. This is the square, represents that there's nobody scored between 0 and 4. Okay? In this case, just to show you, I laid out my points, right? So one person scored a 7, one person scored a 10, nobody scored in the 13, 4 people at 16, 6 people, right? Same thing. So I laid out all my points, right? This is how I do my polygon. This is what I said in the last example, only I just had it drawn out for you. And I labeled it again, this time table 2, the frequency distribution of the number of days served in prison. So for some reason, the author of this book has some kind of attachment to prison or fixation with prison. I don't know quite what it is. However, he doesn't seem to be very well educated on prison because nobody goes to prison for 6 days. That's not the way it works. It should have said years instead of days. The distribution of the number of years served in prison. However, whatever. That's what he wants, that's what he gets. So I laid out my points, I represented my absent scores with a dotted line, and now I'm just going to make my connection with straight lines, right, to complete my polygon. And this is how you do it when you have a larger span of scores, when your range of scores is bigger than you want to list. So, and we're going to learn about range coming up. Yeah.
So that's when you use midpoint, is when the range is a lot larger?
When you're using intervals.
When you're using intervals.
Anytime you, right, so you use intervals when your range is larger.
Mm-hmm.
And when anytime you're using intervals, when you want to do a polygon, a frequency, a polygon of any kind, then you use the midpoint on the x-axis. Okay?
Got it.
Hope that clears things up a little bit. All right, so there we are. We come to the end of section 8. So we're going to move right along and start talking about some of the other shapes that we're going to encounter, right? Because remember I said way back, we don't really see things in straight lines. We talk a lot about curves. And so that's where we're going to move into right now. All right, so now we're going to move on to section 9. And the shape of distributions, right? So all along now we've been talking about the distribution of the scores, the frequency of different scores, how the scores are distributed across the range of scores, right? So earlier when I was doing the polygon example, I said we typically don't talk about things, we don't use those, we don't use a lot of straight lines, because what we like to talk about is the curves. And there's a real reason for this. It has to go on if you're a mathematician, if you go into calculus and all those things. Everything is about the area under the curve. It's the mathematical model that we work off of. And in social sciences and in statistics, the mathematical model, the ideal model, is what we call the normal curve. Right? And what we really saying is, if we study an entire population, and we're going to get into this, don't worry, this is what your curve is going to look like. That the mean, the median, and the mode will all be in the same place. The curve is exactly symmetrical. This is symmetrical, whether you believe it or not. And the mean, the median, and the mode are all in the same place. And 50% of the people scored higher and 50% scored lower. And this is what we call the normal curve, or you may have heard some people refer to it as the bell curve because of the bell-like shape. Right? This is the most seen curve in nature. This is what science has come up with. Some of the other things we're going to see is, so this is the normal curve. So right, I talked earlier sometimes about the scores being skewed when there was a lot of high scores or a lot of low scores, right? In the normal curve, there's an even distribution of scores. And the majority of the people score in the middle, which is what average is, right? So, in the skewed, right, that means either there was an overabundance of low scores or an overabundance of high scores. right? And it shifts the data from the normal curve. And in this case, we're going to talk about, this is the positive skew. Now, I know this is kind of counterintuitive, right? Because this tells you that the number of people, more people got lower scores than high scores, right? Because your scores would go from low to high here. However, it's named after where the tail is, not where the hump is, right? It's for which way the tail is going. And in this case, the tail is on the positive end. Okay? Right? Because if you look at this, this would be the positive side, this area, and this would be the negative side. And the same thing here. So here's a positive skew, and conversely, when there's an abundance of high scores, you get a negative skew. So here we are. That's it. The positive skew, because the tail is on the high end of scores on the positive side, negative skew because of where the tail is on the negative side. So it's about where the tail is, not what the score is. Does that make sense? That's just the same way. It's counterintuitive. It should be the other way around, but it's not. So this is just the way it is. I don't know why. It wasn't around in whenever 17 or 1800, whenever they decided, but that's the way of the world, right? Now, life is always not so simple, right? And so sometimes you can get more than one mode, right? When we talk about the modes, right, it could be any number of them. It's the most prominent score. How many people scored? Like, so if the most people scored an 8. If 6 people scored an 8 and 6 people scored a 4, then those are both, and those are the both highest frequencies. Then those are both the mode, right? There's more than one, and in that case, you would come up with a shape that looks like this. And then this is the example I just said. This would be 4, like, and this would be 8. Right? And this would be a bimodal curve. And as I said, most mathematicians spend their lives trying to figure out what the area is under all these squiggly lines. But we're not going to bother with that. Okay? But this is just how our data is going to look when we represent the distribution and the shapes in the curves rather than the polygons. And this is what we're going to do most of the time. And we're going to be referring to this normal curve over and over and over again throughout this class. So, as I've said many times, you can't just, now that we finished Unit 1, you can't forget about it. Everything carries over to the next. And at the end of the class, we're going to circle back to stuff that we're doing right now. So, but this is it. The normal curve, I am going to be talking about this constantly throughout the class. Okay? All right. We're back. And we are going to talk now about the mean. So the mean, or the average, is the mean is one type of average, but it's probably the average you're most familiar with. It's the one you probably think of. It's the one you were probably taught most and used most in school up until now, right? So the mean is basically represented by a capital M, a small m, or sometimes for statisticians they like to use x with a bar over it, right? And the mathematical formula for m is equal to the sum of x over n. So the sum of all your scores, you add up all your scores and all, right? You get that total, and then you divide by the number of subjects you had. And that's how you get your mean, right? So, simple example. If these were my list of scores, when I add them up, I get 55. I have 1, 2, 3, 4, 5, 6 scores. N equals 6. M is equal to 55 over 6, which is equal to 9.166 or 9.17. Right? Quick, simple, easy. Right? Simple division problem. That's it. And this is our mean, and this is what you're used to talking about most of the time, as I said, and we're going to use this a lot. However, this is not always effective when the scores are skewed or you have the bimodal curve in those things, right? So then the mean is offset. It's not in the center here with everything else. It's over wherever the abundance of scores is, right? So the mean doesn't necessarily represent the middle anymore when the scores are skewed. So then we need other types of averages to look at, or other types of measures of central tendencies. Remember this. Mean, median, and mode are measures of central tendencies. What's in the middle of the group? What does the average person look like? Right? That's what we're talking about here. So we need different types to talk about because of those skews and those different things that happen because people are not simple. They don't always end up being average. Right? So the next one we're going to talk about is median. Median a lot when it comes to the price of things. You don't want to buy the car in the most expensive place. And it doesn't mean that everybody paid that price, right? That's just the price in the middle of all the price range. So let's see if I can get here. So what we're talking about is the middle, right? So if I have a list of scores, I have a list of scores. I want to know what's in the middle. So I have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 scores. If I want to know what the middle is, what do I do? If I want to know what the middle, half of something is, I divide by 2, right? All the time.
Yeah.
Right? So what I want to do here is I want to arrange, and this is done, right? I arrange these scores from the lowest to the highest, right? Your scores don't come that way, but oftentimes we're going to go through a lot of, and this is the process you're going to go through a lot of times to get them in an order. 50% of the scores. There's 11, half of that is 5.5. So if I count 5, this is the simple way. Of course, you're not going to do this if you have 1,000 scores, right? But you're going to do this, right? So I'm going to count 1, 2, 3, 4, 5. And I'm going to count 1, 2, 3, 4, 5. I did that wrong somehow, I'll say. And because I have a odd number, I actually have a number in the middle. So the median in this case is 81, right? The middle score. It's exactly in the middle of my 11 scores. What happens if I have an even number of scores?
You're asking me?
Yes.
Oh, sorry.
I'm asking you. So if I have an even number of scores, right? Right? So I have 1, 2, 3, 4, 5, 6 divided by 2, and I count in 3, and I'm like, I'm here in between those two scores, right? I'm not, that's an even number. So what I'm looking for is that number. What is the number between these two scores? right? And so between 7 and 10, the middle is, in between those two numbers is 8.5. And I would get that no matter what the scores is, right? Because I would add that and divide by 2 to get the half. Right? To get the midpoint between those. I would add them and divide by 2. What, are you laughing at my handwriting or the?
I know how stupid I am.
Right? So if I want to know the middle between whatever it was, if this was 798 and 1002, I would add those and divide by 2, and I would know what the score is in between them. Okay? And that's how you find the median when there's an even number of scores. Right? It will end up, what is the number between your two middle scores? All right? Does that make sense, I hope?
Yep.
Pretty simple concept. About your skewed curves, right? So what if you had some scores like this instead? Oh, I didn't need to erase all that, huh? Right? When you talk about skewed scores, so here we got, right, a grouping of scores, 3, 3, 7, 10, 12, and now 229. This throws the whole thing off. This skews the data because it's so different than the rest of the scores, right? So how do we do this? What does that mean? Right? The same thing, but this will give us, right? The median is not going to be affected because we're not looking at the amount of the score, right? We're just looking at the numbers. So it's the same thing. 1, 2, 3. 1, 2, 3. 1, 2, 3. And again, the median would remain the same. Yep. Right? However, if you drew this graph, it would have a tail. Okay? So that's why we have these different measures of central tendency, because depending on our data set, we need use different ones for different reasons. And to make sure our statistical data remains realistic and significant, and it's not thrown off by 1 or 2 people, or what we eventually call outliers, and you'll learn about the outliers. I'll talk a lot about the outliers, the people in this little part of the curve. Okay? So, there we are with mean, and now, last but not least, we're going to talk about mode. The mode is another measure of central tendency, and it's what score has the highest frequency. What score did people get the most? Right?
Mode equals most.
Mode equals most. There you go.
That's 5th grade.
That's it, right? So, really simple, right? You have a list of scores. Right. And now we look at the list, and here we go. 2, 1, 1, 1, 3 sevens. That's the most, right? So the mode here is 7. Right? Nothing to it. There's more 7s than anything else. It's just that simple. You know, and obviously when we're doing in this class, we're using a lot of simple examples, right? And I'll refer to this all the time too. We don't bother to do research on 10 people. That doesn't hardly tell us anything. It's not an adequate sample to give us any real data. So, we don't want to get into all the messy stuff about what goes on. All right. Mean, median, mode, measures of central tendency. That's what you want to know. Those are your key words for this section, right? And so now we're going to take a change and move on to section 12, variability and range, when I was talking about range, and the interquartile range, which is which is one of those pieces that just seems to confuse people, right? It's fairly simple again, but for some reason it's a harder concept for people to grasp. But we're going to get there, okay? So as I said, I mentioned range earlier very quickly, and I told you we would get to that and what that means, and here we are at range, right? So we're talking about variability, the variability between scores, and you saw that, right? All along I've been listing the scores, and somebody scores a 6 and somebody scores a 20, right? Somebody in our histogram and our polygram, right, we had a range of scores. And the range is really the difference between the highest and the lowest score, right? And when I say difference, what do you think of?
Subtraction.
Subtraction, yes, exactly, right? So if you want to get the range, it's really easy. We take the highest score and subtract the lowest score, and we have the range. Just that simple. Nothing to it, right? Just that easy. However, we always have those people, and I erased them, right? But I just refer to the outliers. In this example, right, we have an outlier, right? Now, this guy has thrown off the entire range, right? Because he is way outside the group, and now this one has a range of 198 because of this one person. So the outliers skew your range. As with most names, they're the challengers, and we'll keep talking about them as we go along, right? So that's what we want to know. The variability and range. Very simple process. You subtract the lowest score from the highest score. And then you're in. Right? Now, the interquartile range is a little bit different. Right? So think about it. I always want you to start thinking whatever language we're using, right, it's still English. So when you see this quartile, what do you think of? Hopefully you think of a quarter, right? A quarter, quartile, quarter. A fourth, a quarter of something.
Quarter mile at a time.
A quarter mile at a time for my friends from Fast and Furious, right? And inter means inside, right? The inside, right? So translate things. It's not a foreign language, right? It's just English. Think about it, okay? So, the interquartile range, then, is the range of 50% of the cases on the two inner quarters. 50% is 2 quarters, right? So the interquartile range is the 50% of the scores on the inside, the 2 inner quarters.
So not below 25% and not above 75%.
Yes, that may complicate things, but yes. All right, so let's talk about it. So I put my scores in order from low to high, right? That's what we want, right? And then I determine what is 1/4 of the score. So how do I do that? I take the total number of scores, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? I have 12 scores, and if I want to find out what 1/4 of 12 is, what do I do?
Divided by 4.
I divide by 4, that's right, see?
Oh my God.
So 1/4 is 3. So now what I'm going to do, I want to find those 2 inner quarters, right? That's what I keep saying. So to find the 2, what I'm going to do is eliminate the one on the low end by counting in 1/4. I'm going to eliminate the one on the high end and count in 1/4 of the scores, right? 3. And now I have my 2 interquarters, my interquartile. And to find the range, it's still the same process. The highest score subtracting the lowest score. Yeah.
Maybe I missed this. Is there certain cases where you use interquartile range versus variability range?
Versus the whole range?
Yeah.
Good, yes. And we're not going to get into that really, but you need, in this class, we're not going to really be using it a whole lot, but you need to understand the concept. Right? So this is your basic statistics class. So though we may not be using this a lot in this class, what happens is if you're a social science major and you're going on to the university, when you get into your next class, they're going to expect you to know what this is, and they're not going to stop to explain it to you. Right? Well, even if you were here, if you go on to take Psych 4, if you want to get it out of the way, you can take it here, and you can take Psych 4, which is a more standard, the next level statistics class. They're going to expect you to know what this is. They're going to glance over it and say, we're going to do this, and blah. And you're going to be sitting there going, oh. Right? So oftentimes, like really this entire class is about getting the basic concepts. And that's what we're doing. And understanding how we manipulate data and why we manipulate data. Okay? So this is our interquartile range, right? You find out what 1/4 of the scores are, whether it's 12, 100, 50, it doesn't matter. You take that, you move on, you cut 1/4 off the high end, 1/4 off the low end, and then subtract your lowest score from your highest score, and you have your interquartile range. Does that make sense?
Yeah.
I hope so. This is a concept that trips up a lot of people. So feel free to reach out to me, come to office hours, and I'll go over it as much as I have to if you need it. Okay? So that's it. Now we're going to actually move on to some math. We're going to start talking about math after this. We got 3 more sections to go in this unit. And we're going to start talking about standard deviation. Right? I know everybody's excited. Because there's nothing more fun than standard deviation.
Dad, don't say things like that.
All right.